Okay, it looks like I might be streaming. Gosh, I haven't even gotten YouTube open, just OBS. So give me a second, guys, if you all are hopping onto the stream already, as I do not even have chat up and open yet. Okay, yes, it does look like we are live. Awesome. Okay. Let me get myself situated here. I'm just gonna manipulate my second screen a bit to make it a little bit easier to have a good view of chat during the stream. Guys, it looks like my microphone cut out there for a moment. This isn't the best cord. It's plugged into it right now. I'll probably have to swap that out, but I will try to keep an eye on that. So, audio should be back momentarily for you guys. Yeah, all right. So, I'm not sure exactly when my audio cut out, so I apologize if I end up repeating myself here. But I just figured I'd start with the blog post while this downloads. So already I'm seeing some really, really interesting stuff here. Like, I've done some work with motion matching in Unreal Engine. I've been doing stuff with animations made in Mogen with animation packs that are already out, but I have no idea how they're pulling off the warped animation montages with motion matching with the parkour here, within the jumping, the vaulting. They showed a little bit of that in one of their Inside Unreal streams showing the 5.4 features, but not enough to begin picking apart how this is all working. So this is probably going to be a big focus of mine for the stream today. Again, I don't know anything about this more than you guys, so we're going to be discovering a heck of a lot together today. Looks like there's a bit of a video here. 30 seconds. Might be what they showed during GDC, I think. Okay, well, I should be, yeah, I'm going to open up the project now, and then I will switch over to it. Let's see. Okay, that's interesting that it doesn't work in multiplayer yet. Okay, Flippy Flops, I will check to see if I can save stuff in the project to make sure that it's not just a, to see if that's a local problem for you or not. Yeah, at this point, I'm just waiting for the project to open now. We're at about 9%, everyone. Might take it a few minutes to get loaded up the first time around. Okay, well, there's going to be a lot of animations here too, so I'm very, very interested in understanding the different types of coverage that Epic has put together for this project. And give me just a moment, guys. All right, I am back. And I haven't even grabbed my reading glasses yet this morning. Getting a bit of a late start today. Probably not the best day to get a late start on. 45% now. Almost there. Yep, we're on compiling shaders. $973 shaders left. Well, awesome. I'm getting excited reading your messages, Flippy Flops. I'm very curious to see what this Locomotion looks like. 500 animations. I'm wondering how many of those are Locomotion related. I do know I'm working with a technical animator who knows a little bit more about the project than I do. And he said that there's a lot of short clips and a lot of different pivot animations. So I'm real curious to see the kinds of coverage they have. I know I'm repeating myself now. I'm trying to come up with things to say while I wait for shaders to compile, guys, but I know nothing about this project past, I think, what I've shared already. Oh, well, one shader left, and now we're back up to 15. That is the way of Unreal Engine. Yes, so yes, tutorials are going to come. I'm going to have so much content to make on the channel. You guys are probably need to get ready to see more than one video a week, finally, again. I might need a little bit of time to pick apart how this project works, but one of the first tutorials I'd like to make is just showing how to get this Locomotion into other projects and working for other characters. So if you have an existing project somewhere, you want to bring this Locomotion system into it, just a real quick high-level overview. What are the basic steps you need to take to do that? And then I want to, after that, go in more in-depth in how it all works as I understand it. I believe that Caleb Longmire, he's the guy who did the Advanced Locomotion System version 4, got hired at Epic Games, and I believe was a pretty big part of this project now that we're going to be loading up. I believe he's going to be doing a stream tomorrow. And I'm not sure if that's going to be on his channel or if it's going to be like through like a Inside Unreal stream, because I do those on Thursdays. Ooh, limited free space on my main drive already. Really? That could be what's slowing this down. Well, I think I'll be fine if I just go ahead and delete all of this stuff right here. Okay. There we go. That's a bit better. Yeah, we can definitely discuss that more over in Discord, Flippy Flops. Yeah. Okay. Let's see. Okay, here we go. It is up and opening now. Just gonna move myself over here for the time being. All right. I'll be facing in the wrong direction due to the angle of my camera, but that's fine. I don't really care that much about that. All right, guys, here we go. So this is my first time in this project. So let's see what it has. Try and full screen it here. Okay. Ooh, I'm getting a bit of stuttering. It's probably because it's loading up for the first time. What is going on here? Yeah, shaders, everything, still compiling. Pretty good footstep sounds. Not seeing any foot sliding. I'm just spamming WASD keys right now. Lots of shaders to prepare. I'm kind of just waiting on the shaders and the stuttering to stop. Okay, that was some good pivots. So we're in forward facing right now. I'm not sure how to switch to strafing yet, but we have some really good turnarounds. So the animation is really keeping up with the capsule movement. And it's faring quite well when turning quickly. Okay, thanks, Michael. Yep, I definitely will keep track of that. I just minimized it over here. Oh, cool, cool. So it's doing runtime retargeting then. So that must mean that this is performant. Oh, that's cool. That's cool. So it's definitely interesting that runtime retargeting is being used in this, because that signifies that it might be like performant enough to really be used heavily in a bigger game. Maybe they are using it in Fortnite then. So it looks like we can enable debug on orientation warping and a root motion or a root offset. And there is a motion matching database level of detail. I have not seen that, so that is very, very interesting. Sure thing, I'll definitely show the FPS. Yep, so I'm getting about 80. I am streaming right now, so that's also going to be using my GPU. If I stop playing editor, I'm getting 90 to 100. So yeah, I'm surprised that they didn't either. I'm definitely going to be cracking open that animation blueprint very soon here. So what does this say? So obstacle courses, okay. So it's not automatic. Yep, we got a bit of stuttering there. So let's try that again. Oh, wow. Okay. That was smooth. So I'm wondering if they're using motion matching on the jumps as well as those vaults. Yeah, that is nice. Wow, that's nice. That feels very smooth. Wow. Okay. So how do we get up here? Oh, teleport. Okay. Okay, I want to see what happens if I miss this jump. Do we, like, is there any grab onto the ledge? That's kind of what I want to see now. So I just got to jump early. No, okay. Does not seem like it. Oh. Hey, Nick, good to see you. Oop, missed it, but that's all right. Okay. There's the teleporter up on the end. It is. Okay. I wonder if I can just get back to it from over here. So step interpolation should work, I think. I'm not too sure. Like you could, I would think it would work. Oh, I missed that jump, but that's fine. The interpolation isn't needed for motion matching to function. You could even maybe have it like choose a new pose at a time interval that matches the step interpolated frame rate you're looking for. I don't know. I would think it would be possible, but I don't know what all the intricacies of getting it working with that would be. But I would imagine it would be doable in some way. Okay, so that's cool. We can step there and it gives us view controls. So movement, yep, all makes sense. So sprint, crouch, there is crouch. Toggle rotation mode is middle mouse button. Okay, cool. So we can sprint. Why is that not working? Did I just misread that? Oh, sprint is coming in 5.5 and crouch is coming in 5.5. Okay. All right, that's fine. Well, I'm very happy that they're going to be supporting this project into the future with future versions of Unreal. That's fantastic. So let's look at the strafe mode. I didn't mean to escape out of that. I was just trying to get the mouse cursor back. I said strafe, I meant interesting. So I switched from strafe to forward facing at some point in one of these times because I was thinking for a minute there the default was forward facing. So I must have hit the middle mouse button unintentionally. There's a bit of foot sliding on those pivots there. That's real interesting to see. Because there's so little everywhere else. It seems to be specifically with the forward facing 180 degree turns. Not a lot of weight shifting. It doesn't feel like there's a lot of weight shifting happening if I do more of these like snaking like movements. So I'm not sure if they have like a dedicated coverage for that. But doing that with the WASD keys feels pretty nice. And then I can hold down control to walk. So there is walk coverage. I don't know if there's flailing. Let's try and test that. let's eject. And just grab this guy. Yeah, it looks like there's a bit of flailing. Let's see. How high up can I get him? I want to get up. Oh gosh, I let go on accident. Okay. Let's really up the speed of the camera. Back out, like, really, really far. So yeah, there is flailing. Yeah, a bit of a particle effect could help with the sliding. I agree. No idea how high up we are. But we are back up to 100 frames per second, which is interesting. It might be because we don't need to be searching a database every frame. Because they're not... I know that they don't have all the animations in one giant database here. So I think we've messed around enough. Let's actually look at this project. Okay, let's see. Characters, UV5 mannequin, nothing there related to animations. So I'm wondering what this is being retargeted from. UEFN mannequin, maybe. Motion matching data. Okay, so I'm very curious to see how they implement chooser in this project. And again, guys, I have no idea, no clue what any of this, how any of this is put together yet. This is my first time looking through all this, so it might take me a bit of time to get acclimated well enough to try and begin guessing at what's going on here. This isn't a watch me explain the project live stream. This is a let's try and figure this stuff out live stream, certainly. I'm definitely going to be trying to get everything I can out of the live streams Epic will be doing or whatever they put out on this as well. Let's see. Lots of animations. Okay, wow. I want to see the actual database assets. And I don't know what normalization sets are. I haven't figured out, like I get of where they're used, but I don't understand their actual function is and how they work. Okay. So this is the Traversal pose search database. Come on, can't I get this to loop? Why does it keep pausing on me like this? Editor's moving a bit slow on me right now, guys. I apologize. So it's not playing this portion of the animation. But it looks like that's like going into the negatives on the timeline. Oh, wow. Okay. That's interesting. So it looks like the timeline's just a bit bigger than the animation here. I keep double clicking instead of single clicking on these. So I'm really trying to understand why. So there's pose search, there's motion warping. So it's like we're seeing little segments of these same animation. This is really... I'm definitely not able to make sense of this part of this yet. Oh, and it looks like there's some actual documentation on this, guys. So let's go ahead and scroll through this together. I'm going to go ahead and switch over. Thanks for sharing that over in Discord, Michael, if you're still watching. Yep, I know. It's not shown on the screen. Oh, the editor window isn't shown on the screen. Thanks, guys. I apologize for that. Gosh. OBS should not be acting like that. Okay. I would expect to be smarter. It should show up on the screen now. Okay, yeah, it does. I apologize, guys. So I will backtrack a little bit. So yeah, I was just looking through this Traversal motion database here. I'll make sure everything stays in this main window here so that it actually shows. I'll keep a closer eye on that. But thanks for pointing that out to me, everyone. And I'm just trying to figure out. So I'm seeing only sections of animations play. And there's some really short entries here in the motion database, which I find very, very interesting. But before we get too deep into this, I am going to switch things over to, and I know the screen went dark for you guys, don't worry. Okay, there we go. Had the wrong scene selected in OBS. All right, so this is the documentation here for the game animation sample project. So the game animation sample project is a project you can use to observe and learn about a modern, high-fidelity animation system in Unreal Engine. The system uses a suite of motion-captured animations driven by animation features such as motion matching to deliver a high-quality and responsive animation system for a human character's traversal system. The system features coverage for common animation needs such as locomotion, scaling ledges, and vaulting. The project is broken up into several obstacle courses that you can navigate as several included characters. The animation sample project is also built to be extensible, allowing you to import your own character to see how the animation system works with different characters, and even migrate the animation sets and systems into your own project to be used and built off of. Well, awesome. I'll definitely look into that and try and show that process in a dedicated video, everyone. So I should have read the README. I forgot to look at that. I'm kind of scrolling past the stuff we already looked at a bit. Okay, so it's showing you how you can implement a character. Really interesting. Okay, I'll look at this myself later. Exporting animations. Okay, animation blueprint. Let's take a look at this. The primary animation blueprint that is used to drive the animation system for the player character can be accessed by navigating in the content browser to, there's a file. I'm not going to read everything out loud, just try and find the interesting stuff. This blueprint is used to drive all of the selectable character meshes and can be opened by double-clicking the asset. The anim graph is the primary graph that controls the pose of the player character at runtime. This graph contains the motion matching node, as well as the supplementary animation nodes that are used to drive the character's animation. For more information about using the anim graph, see the anim graph documentation. I wonder if they updated the other documentation here. And for more information about debug and observation tools, see the debugging. Okay, motion matching. The animation system contained in the animation sample project is built around motion matching, an animation system that queries a system, in this case, the character's movement model, to select animation poses from a database of animation assets, to select the best pose to the character's given position and momentum. The motion matching system uses the motion matching node in the character's animation blueprint to select a pose at runtime. Pretty standard stuff so far. Okay, so we're going to definitely take a look at the bound functions to these nodes. That's interesting. The motion matching node uses an anim node function to perform the requisite logic in order to make its selections. You can open the animation node function graph by selecting the node and using the eyeglass button. So standard stuff here. Same bound nodes they used all over the Lyra project. The update function. In the update function, you can observe how first an evaluate chooser node is used to select the active pose search database asset the motion matching node will use to select an animation pose from. This is to limit the data the node must search in order to control the results the node can select, as well as improve the performance of the system. You can access the chooser table asset. There's the path for that. Good to know. Post search database in the content browser, good to know. Post history, that's pretty standard. All right, well, let's get back to the project and go ahead and open up that animation graph, everyone. I think that is probably going to be the best way for me to get acclimated with this project quickly. So if I can see where these databases are implemented, I'll have a much easier time of understanding how. So let me go back to that documentation and see where that path was. Okay, so content blueprints, and the animation blueprints is there. Got it. Okay. And I'm going to take a moment to finish off this coffee real quick, everyone. Gonna need it. All right, let's get started. So this is our Anim graph, and those are some massive comments. Well, I'm gonna need to read through these myself, so I'm just gonna read them all out loud to you all. And chat has not been coming through for me. Like, people might not be sending messages, but YouTube gave out on me, didn't update the chat for a really long time during one of my relatively recent streams, and people were sending messages and YouTube just wasn't updating, so I don't trust it anymore. And you can't see it. Well, why does it keep opening in a new window? Thanks, guys. And I guess I can see chat. I'm just very, very mistrusting of the chat right now. Not you guys, but just a YouTube system. Okay. So this is the animation graph here. And I'm just going to switch OBS to the display. That is not my display. That is my webcam. So there. Or not. Okay. Let's see. Now can I reshape it? There we go. So now you guys will just see everything on my screen, and we won't have to actually worry about stuff not always showing up. Okay. So I'm just going to start reading through the comments. I need to read through them myself, so I'll read through them out loud on stream. So the motion matching node is the primary anim graph node that drives post selection in a motion matching system. Motion matching node requires two key components: post search database, post history node. In the example setup, I guess I'm skimming, guys. The post search database asset is set in the update motion matching function. Okay, same as what was said in the documentation. Oh man, gosh, that's a good one, Michael. That's a good one. I'll do my best. In this example setup, the post search database asset is set to the update motion matching function, which can be viewed in the node's details panel. Okay, motion matching node, you can use the blend time float input to dynamically change the blend time. Motion matching node also has two anim node functions on update, motion matching, using a chooser, same stuff that that we saw in the documentation so far. So I'm just really skimming through this. All right, that's enough reading. Let's actually take a look. All right, so in our motion matching node here, this seems to be driving the entire graph. So they are switching databases at runtime, but they're not doing so in a state machine, which I'm very excited to see, because I haven't spent the time really playing around with this to figure out how to really swap databases at runtime without using state machines or blending between multiple motion database or motion matching nodes. And as far as I can tell, when blending between multiples of these nodes, you can just encounter the same blend issues you could get in any other Locomotion system with stuff just not being lined up. But if they're doing it inside the node, it would make sense that it's going to match to whatever it is swapping to. So that was like one of the big issues when I just chucked the Lyra animations into a motion matching project for a video earlier on my channel, just as a quick test. So I'm very curious to see how they implemented this here. So they have a bound float for the blend time. It can be changed probably over here. there is a blend profile, which is fast feet plus root weight. Interesting. What does that look like? Let's go take a look at the skeletal mesh, blend profiles. So the root is given a value of 2, foot IK a value of 1.5, so it's making the root twice as fast as everything else, and the legs and feet 1.5 times as fast. So that's interesting. I wonder how that compares to just like a normal fast feet. Hermite cubic in out. Standard settings for the jump threshold time, reselect history, and search throttle time, and they're not updating those at runtime. But they do have a min play rate of 0.85 and a max of 1.15. No inertialized blending here. And what is this should filter notifies? A flag that determines if any notifies from originating from any I'm sorry guys, that sentence structure really threw me off reading that. I'm going to start over on this. Flag that determines if any notifies from originating from, yeah, I don't know why it's typed that way, and Anim player samples, Anim player samples. I'm lost. I'm going to try this again. Flag that determines if any notifies from originating from an Anim player samples should be filtered or not. Any notifies originating from an Anim player sample should be filtered or not. Okay. Okay, that makes a bit more sense. There's some really bad sentence structure there. Yeah, probably a typo. Max blend in time to override. Player depth blend in time multiplier. Not sure what those are. I'll come back around. So let's look at the... I'm not sure if we should look at the blend stack for this or the bound functions. Okay, so let's start with the update functions and then take a look at the blend stack. I haven't worked with blend stacks much. That's a new feature, I think a relatively new feature again. And so I have not covered those on the channel yet. Okay. So let's look at our... So that's interesting. What's the difference? Wow, okay, there's a second bound function. I've never seen the binding for on motion matching state updated. Is that just specific to the motion matching node? I'm going to grab a motion matching node. Okay, there's a drop down here that I just missed looking at that one. I was only looking at the grouping up there. Darn, there's nothing to come up here when I hover over on this. That sucks. Do they explain this in the comments? Yep. Not clearly. On motion matching state update, which calls the update motion matching post selection function. Okay, here we go. It allows us to perform additional logic based on the result of the motion matching selection. In this case, we cache the database the selected animation is in so that we can grab any tags it has, which can be used for future selection logic. The tags are grabbed in the event graph due to a thread safety issue. See current database tags. Okay, that's all sufficiently confusing for me. Hopefully just as confusing for you guys. Or hopefully less confusing for you guys. I'm not going to be that way. And I can't really make much sense of this yet, is all I'm trying to say. If you guys have some insight, I'd definitely appreciate it. So on update, we are evaluating a chooser and setting a database to search in our motion matching node based on this chooser. And we're getting an interrupt mode. And so let's actually... I can't call that. I'm just trying to get a... Here we go. Okay, these are the interrupt modes, which are pretty important. There's the do not interrupt, interrupt on database change, and invalidate continuing pose, force interrupt, and invalidate continuing pose. And what you have this set to can really change the behavior of the database. Can't speak to it more than that. I have not worked in depth with motion matching stuff. I've kind of been waiting for this project to come out to really get a feel for how Epic does it first. So this is going to be really insightful here, I think. I guess I'll have to read the comment. This function controls the interrupt mode of the motion matching node. This determines whether motion matching will force a blend into a new database if the selectable databases have changed, or wait until it finds a match that costs less than the currently playing animation. By default, we do not interrupt. However, whenever a core state has changed, we know we want to start playing a new animation, therefore force an interrupt. This prevents motion matching from sticking in the idle if the character has started moving, or staying in a cycle animation if the character wants to stop, which can happen based on the continuing pose bias tuning. Essentially, this keeps motion matching responsive to changes in core states. Okay, that at a high level makes sense. I comprehended 2/3 of that because I was reading it out loud, and I don't comprehend as well when I read out loud. So I might need to go back and read that silently, guys. So let's just look at the actual chain of logic here. We're either not interrupting or we're interrupting. So if we're not interrupting, we're allowed to continue the previous pose, but if we're interrupting, we are forcing a new pose and invalidating the previous pose, even if it was scoring all right previously. So that makes enough sense, and now I just want to understand what the conditions are that are causing that. So we have movement mode, which is either on ground or in air, and the movement mode from the last frame. So if we change from being in air to on the ground, we force an interrupt. Okay, that makes perfect sense. So this is saying that while we are on the ground, any of these conditions can force an interrupt. Okay, so if the movement state is not equal to the movement state from the previous frame, and this is idle or moving, all right, makes sense. If a gait is not equal to the gait on the last frame, and that's going to be walk, run, or sprint. And if stance is not equal to the stance last frame, and that is stand and crouch, although they do not have crouch fully implemented yet and won't until 5.5. So that makes sense. That all is pretty logical. Not sure if I would have thought of going that in depth myself, so I'm glad that they've done that. And now, that's interesting. We're evaluating a chooser and returning multiple results. So can you just evaluate a chooser and return an array, or does the chooser specifically return an array instead of a single reference to a data table? Let's look and see. The output object type is a pose search database. The result type is an object result. Interesting. Very interesting. So I want to remind myself of the standard evaluate chooser node here. Okay, so there is the mode, and you can return all results. So I guess that's if okay, so I've not worked a ton with chooser yet either. I've only recently started working on it in another project I'm working on, but not for Locomotion, but that actually for combat animation selection. So this chooser is still relatively new to me as well. So my best guess, and I could be wrong, completely wrong, but my best guess is that when the chooser is set to the all results mode, it will return multiple valid results if there are multiple valid results. It's not going to give you every item in the chooser if something just is not going to work or returns false in whatever that choosing logic is. I've looked a bit at the source code for chooser, but not into it with enough depth, so I'll probably have to look at this in a bit more depth before I cover this stuff in a dedicated video of any kind. So let's actually open up that chooser again. And there are 3 databases here, which I find interesting. I was kind of expecting there to be more. So there's a dense, a sparse, and it defaults to dense. Okay. Okay. So I really like this idea. It's a really interesting way to kind of solve the issue. So there's a sparse database, which I'm guessing is for like if characters are far away, you can just, they don't need to play as many animations, or if it's like an NPC, like you can switch the database based on this float here and use a sparse database as opposed to a dense one. So let's look at the sparse database and see what is considered as sparse. Okay. Gotcha. Got it. So we were looking at choosers and not databases. It took me a second. I was being a bit slow there. So it's a chooser table that chooses chooser tables, and that's why there are more than 3 databases. That makes sense. So inside the sparse data table, we have stand idles, stand walks, stand runs, and in air. And for those of you who aren't familiar with chooser, it's really powerful. I really want to cover it on the channel soon. I haven't used it a lot, but I feel that I'm getting the hang of it relatively quickly. There are a few points that I want to explore more to get deeper understanding by looking into the source code. But you can just add columns here and set conditions, and it'll just choose this stuff. So like this would replace a lot of the, like this could be a full-on replacement for the linked animation layer setup that Lyra has, for example, where you don't need like an entire other animation blueprint just to swap animations at runtime. Chooser is designed to swap animations at runtime in a thread-safe way and in a performant way. So this is going to be the way to go moving forward. So in this case, the stance, movement mode, movement state, and the gate are all influencing the selection here. So can I do like a quick... so is this a nested chooser? It is. So it's nesting a chooser inside of a chooser. So we're 3 choosers deep now. And this is the stand idles. And we're returning up to 6 databases for standing and idling. There's a database that's... So it looks like the... So we're in the sparse database, I think. Yeah. And the stand idles. Maybe we're not 3 choosers deep. I feel like I went in a circle there that I didn't intend to go in. There's like another chooser here too. Yeah, the soft references point is a valid one. I'm not sure what the memory usage looks like with these. That is a good point. Though they didn't use soft references anywhere in the Lyra project either, with the linked animation layers approach. So it's going to at least be more performant than that, I think, and at least just better to use, certainly. I threw myself through a loop there, everyone, because I feel like I was just looking at a different chooser somewhere. Did just replace one of the tabs here. So we're going to our next chooser table, which is going to be our dints. That's what we were looking at. And now we have our nested chooser table. So the sparse does not nest chooser tables, and the dints does nest chooser tables. Okay. So let's start with the sparse, because that's going to be a quick bit faster to understand here. So stand idles, walk stops, run stops, lands, lights, lands heavy, and turn in place. Interesting. So the sparse chooser table, like I'm not seeing much general locomotion stuff. Oh, we're switching these based on level of detail. Stops and idles. Huh. So I'm just trying to understand the chooser structure here, guys. So based on the database level of detail, we're switching between dense and sparse and defaulting to dense. Sparse is holding idles and stops and turn in place, and dense is holding idles, walks, runs, and in air. So There's starts. But I'm not seeing lots of stops here. So maybe I'm misunderstanding the usage of the level of detail. I'm going to look at the actual references. Okay, we are setting this, but we're setting it with the console variable. So it's not being changed in the logic based on state. So what's confusing me here is like where are the continuous loops in the sparse data set? I'm just going to start opening up these databases. So this is it in the idle database for the sparse chooser. So these are our stops. Left foot and right foot for backwards, forward, left, right. Starts. So backward starts for strafing, it looks like. We're switching our facing. Forward. No refacing for left. And no refacing for right. Interesting. Same setup for walking. Probably similar for run stops. Yeah. Then there are pivots here. Okay, a lot of pivots. This is exciting. I'm really curious. So 90-degree pivots. Okay. That makes sense. Variants for the left foot and the right foot. So the variables here seem to be direction, left foot, and right foot. And that was a weird side step in that one. I guess it's all right. And I have not been keeping up with chat, so I apologize. I'm going to catch up on that real quick here. And guys, I don't want like too much of just air and stuff to go in there and blow it out for you all, because I can adjust that if I need to. Okay, yeah, I do like the way that the chooser selects stuff based on the state machine. I mean, not based on, like, in comparison to the normal state machine approach. Like, it's just really nice and compact and gives you a great, like, overview of all of your conditions at once, which I really like compared to the state machine. But I am interested in really looking at the size and performance stuff related to the hard references as well. Looking at a chooser table, yeah, you can return an object result or a class result, but there's no option for a soft reference. So yeah. Seems like Epic is using it this way, and they're using it in Fortnite. So that there's motion matching with chooser tables working for 100 players at once in a level. Like, not all those players are going to be on screen at any given time together in a lot of cases, and the Anim instance runs locally, so I would expect it to be pretty performant. So it seems like it's all right with the hard references for at least Fortnite. But again, I don't know how different their setup is from this here. Could be very different. It's hard to tell. But they developed, but it would make sense that they'd be using Chooser in Fortnite. I would expect them to. They tend to use this stuff in Fortnite before we get it. So, and then we get it because they use it in Fortnite. So where were our pivots? Okay, so yep, we have. Yep. So this is like a box stance card that's been split up where the character is facing the same direction and doing 90-degree turns. And there are variants for based on the turn direction and the foot that we're pivoting on. Like there was a left foot. So I'm not sure why there were two lefts, like two L's there, because there's just one turn. But then there's the right RL. So what's the difference between these animations? That's what I'm trying to figure out. So that's the timing of the turn. So what makes this RL? Whoops. And what makes this LL? So that is our left foot that we're pivoting on. Are we? It seems like both of them are almost going down at the same time. That's definitely our right foot we're pivoting on. I keep double clicking. Ah, darn, why do I keep double clicking? Okay, let's try this again. So we're pivoting on our right foot, which matches this, and we're moving backwards, which matches the B. It's from like a box stance card. We're running and our stance is neutral. So all of that makes sense to me with the naming convention. What I don't get is the RL right here and what that means. We're going from backwards to left. So what's the R? Because there's an LL for the right foot, and I double clicked again, and that's going left. So why is it RL and LL and not like RR or just L and R? There's a second L in the naming convention that is really throwing me off. And I want to understand what it means. Because down here we have like BLFR. Okay, so we're pivoting down here, but not up here. We are changing directions, but we're going from backwards to left. Let's look at the cycles. Okay, so we have B. So BL is 45 degrees. BR is 45. So that's like our 135 and 135 degrees. Similar naming convention is the advanced locomotion system, animations. So that makes sense. Okay, I see. So LL is left. So it's like all the way left because forward is forward. Forward left is 45 degrees. Forward right is 45 degrees. Left is 90 degrees. There's a left right offset. Okay, I'm just not going to bother with that yet because then right left. So why is it right left and not right? So maybe that isn't the naming convention here. You don't understand why there are these offset animations here. So what's the deal with this L? If we're going off of the naming convention as I would expect it to be. So right left, is that? So in left, we are facing backwards into motion. From right, we're facing backwards into motion. For right, we are facing backwards into motion. So it might have to do with the actual facing of the hips relative to the velocity vector on a 2D plane. That's my guess right now. So I'm going to re-examine this. So we're going left. So is left left forward. Or left backward. And right left is left backward. And then right is right backward. But right left is going to be right forward. Yep, there it is. Okay. So right left is right forward. So our hips are facing forward into motion. And right is hips backward while moving right. Left is hips forward moving left. Or no. So left is hips backward moving left, and right is hips forward moving left. So that is not the naming convention I would have used at all. I'd be curious to understand the logic behind it, but I can make sense of it now. So let's get back to actually looking at the pivot animations that are here. The thing is, the foot is at the very end. So, and it does seem to be correlated with the direction of the hips and the facing of the body as a whole relative to the movement, like it's a forward-facing gait as opposed to a backwards-facing gait. I would expect it to be the foot too, except that the foot doesn't match. So here we have LLR foot, RLL foot, RLR foot. So there's no, it would be having the same information twice, and there is no clear connection there. So my best guess, it has to do with the facing of the gait. But that's why I kind of prefer like a HF and HB naming convention, where it's like hips forward into movement or hips backward into movement, which is something a friend of mine, Ryan, came up with and used in his unarmed upright strafing animation set that I featured on the channel somewhat. So there's 180-degree forward facings, 90-degree forward facings, starting from different directions. So the different variants you'd have for that: 45-degree pivots that I guess would line up with the specific loop for 45 degrees. So it's not just reusing the forward pivot for 45 degrees, which is for forward facing. So it's interesting they're using that much coverage for forward facing. But then they're also no, they need to do 45 degrees because we've moved into strafing. Haven't we? So are strafing and forward facing in the same database. So this is really interesting. That strafing and forward facing pivots are in the same database. It looks like that looks like there's not actually a separation there. I can see why you'd need the 180-degree forward facing pivots if I'm pivoting using the mouse, so that makes sense, but this would also mean that the strafe pivots are there when we're just using forward facing. So I would want to really look at what that middle mouse click does and where that input action is processed and how it affects the selection. And if it's, I wonder if it's only changing the behavior of the character and not tagging anything in the animations or in the animation set. So in these animations, there are noise events, speed curves for the feet, and a curve to enable orientation warping. And I accidentally clicked off of Unreal Engine. My bad. Oh, I keep doing that. What's going on, computer? Okay, let's try that again. And we're disabling orientation warping during the pivot. Interesting. I wonder why. Gosh, I'm gonna have to spend so much time just like seeing what happens if I don't use the enable orientation warping curve and all these little things to really understand, because I've never personally found the need to enable and disable orientation warping on pivots. I guess that's only because I relied on like the maximum angle limitation to keep the weird like 180-degree leg flip from happening. So it could really be just to stop the legs from doing that quick switch around during the pivot. So that makes sense. That makes sense, I guess. But I'll have to see if that occurs if I just don't plug in that curve. So there's going to be a lot of reverse engineering here, because I really want to understand the logical steps taken and the reason that everything is in place in this, so I can take all of this and use it in my own systems. So we're switching between dense and sparse, and then in our sparse, we're looking at these databases here that we've opened here. And some of these are like, we're using this dense stand idle loop, probably because this is used for dense as well. And there's just one standing idle. Maybe there's like no idle breaks. But in dense, we have a lot more of these. This has our traversal, our lands, different jumps, it looks like. So the actual walks themselves. Okay, so I think the difference in the dense is that there are transition animations from the different speeds. The pivots don't look that different to me, but there are additional databases here. And there are shuffle animations. So we're switching the foot. Huh, okay. So the character is doing a shuffle here to change the ordering of the feet. No, maybe not. No, it's just shuffling instead of strafing. Maybe that's just to add variety to the motion. No, it is shuffling. It's switching from left, right to left, left. Okay, so we start with our hips forward into motion, and we end with our hips backward into motion. Okay, so that's what's like not there in the sparse data set. I think I can do a more in-depth comparison in my own time. But the dedicated shuffle animations make sense, and I need to close out of some of these databases. I'm losing track of where I'm at here. So I like the shuffles as opposed to spins, because you can do a spin animation, but a lot of times you just don't need to do a 180-degree spin. It's the least efficient movement. Like a shuffle makes a heck of a lot of sense, so I like that. I do wonder if there are spins anywhere too, because I feel like I've read that somewhere in this project. Yep. Okay, so these are for the refaces for starting. And the actual hip-facing switch at runtime is the shuffle. I like that, personally. Though I would still like to see, what I don't see here are like spinning. Maybe I just missed it. I'm going to open up the run pivots. And I'm curious to see if they implemented like spinning back foot pivots. Or the character does like a 135-degree spin because it's closer to the actual foot. So there are like pivots at 45-degree angles as well from a diamond. Okay, there's hourglass as well. I did not scroll far enough. So from 45 to 90. So it's like, is that like a 22.5-degree turn? No, that's like a 135-degree pivot. The dance card terminology makes sense that you're breaking up pieces of a larger movement, of a larger pattern. Okay. So this is the dense, and that's why I didn't see these earlier. So there are a lot more pivots in the dense data set to get, I guess, higher fidelity coverage. And it'll do what it can with the lower coverage in the sparse, so that makes sense. And what the sparse one didn't also seem to have is actual curved trajectories like this one does. And so in the actual pivot database, this is where all of the turns are. That's what I'm talking about, the back foot. I guess that wasn't really an example either. There we go. That's one. Okay, so a lot of really fantastic coverage, guys. That's definitely the case here. So I think we have a pretty good idea that we're, at least at a high level, choosing between a sparse and a dense dataset based on an integer that can be set as a console variable. And in the dense, we have nested chooser tables and more pose search databases, so more coverage. And that's all I think we need to know about this right now. That I want to know about this right now. So now let's actually look at our on motion matching state updated bound function. Gosh, we are an hour in, and guys, I don't want to stream for too long today because I'm probably going to hop into voice chat with some other people I know and work together to pick this apart at some point. And I don't want to leave them waiting for too long today. But I'll definitely have lots of videos to make. Maybe I'll go for another 30 minutes to an hour, see how far we get. So this function is called after the motion matching node has selected an animation. In this case, we cache the database the selected animation is in order to grab the tags in the event graph. Due to a thread safety issue, in the future we plan to use this function to control additional things such as blend time and blend profiles based on the selected animation. So we get the selected database and we're tracking the current selected database. So it's talking about tags and stuff being tagged. I want to understand how and where, so I'm going to find the references to the current selected database here. So does this tags just belong to, like, does every database have like a set of tags? If so, then I'm just not aware of that. So let me promote this to a variable. It is a post search database type. Yeah, I guess so. So I'm going to go back over into a database. And where do we find those tags? Okay, here we go. So there's an array of tags that we can add to databases. That is really interesting. And okay, yeah, this is kind of reminding me of some of the earlier Ubisoft GDC talks, or just conferences they talked at and presented on motion matching and tagging datasets. And I guess this is where you do that in the Unreal Engine implementation. That's good to know. I'm surprised I didn't come across this. So now I just kind of want to look until I find something that is actually tagged to see what some of these tags are. Okay, we finally have a tag, and it is in our turn in place, it looks like. And this tag is turn in place. Okay. So there is a turn in place tag. Are there any other tags? I'm opening so many tabs. Lost my train of thought. I apologize. Where were we? Tags. That's it. Okay, we have a new tag in our pivots. And that's pivots. Okay, so they've specifically tagged turn in place and pivots, which is really good to know. Tags will probably play a pretty important role. And maybe filtering what gets selected. I don't know. I'm all just guessing at this point still. So we're getting to some of the traversal stuff. So I'm curious to see if we run into more tags here. Is there going to be like an in-air tag? Doesn't seem that way. I'm not checking every single one of these, but okay. So now before we go back to the animation graph, this is something I forgot to do earlier. And let me just close all my other tabs here, because these are getting to be way too many to handle. I want to find, okay, walk loops. So there's a normalization set for dense, but there's also a schema. And there's a default schema, a jump schema, a stop schema, and a pose search traversal schema. Don't know why I said pose search on the last one and not the others, but I'm really curious to see what the channels are that they're searching through and if they have the default values. So the trajectory has a weight of 1, and the pose has a weight of... Okay, so there's not a pose channel, there's a group channel. It's so structured a bit differently, but still getting a pose. And what's the weight? So the weight on the pose seems to be heavier if they do get added up. So we're tracking the left foot, the right foot for their position at a weight of 1. And I see, so the group allows you to group multiple bones together with the same settings. That's useful. Tracking the left foot velocity and the right foot velocity. Same settings, but separate groups. Not sure why that is. There's the heading, which maybe might be the facing, I don't know. For the pelvis, yep, okay. In the facing for the pelvis to stabilize the motion. Okay. Okay, cool. So it seems like pretty standard stuff. Oh, I did forget, I do want to check the trajectory settings here. So the trajectory sample, when does that actually sample? What intervals? So not nearly as far in the past as the default, I think. Yeah, so this is 0.05, and the default is -0.4. That's very interesting. So facing direction and velocity, facing direction velocity, facing direction position and velocity for the final one. So kind of closer to the kind of approach I think I've stumbled into a bit of not using position as much. But that might be default, so maybe I didn't stumble into it. I could be misremembering here. There are walking animations as well. So there is full walk coverage and full run coverage. Full crouch coverage will be coming in 5.5, along with sprint coverage in 5.5 as well, whenever that may be. Okay, so I feel like I have a better understanding of the databases, coverage, and post search. I say that, and then I remember that I wanted to look at the normalization set. We'll come back to that. So back in our... So we are getting our current database tags. So I'm going to find all the references to our current tags. So we're getting our tags when we're starting. Not sure what this is being called. And we're checking if it contains pivots. So we are doing some logic based on our tags. That's good to know. And we're checking if we should spin or if we should start. I don't know where those functions are being called at, but I think we'll eventually encounter them. So what is the update motion matching post selection? So that's storing our current selected database. And I guess that's kind of where we were back before. So find references. We're getting it to set our tags. But we also get it in our blend stack graph. So let's go. So that you can access by double clicking on the node here. And so this is really cool, guys, and it's not something I've covered on the channel yet. But so I know the normal approach that I've shown on the channel that was used in Lyra, because I don't think blend stacks were added yet in Lyra when Lyra came out with 5.0, is that you have your sequence player or your sequence evaluator, and then you have your orientation warping, your stride warping. And that's fine, but with motion matching, you could be changing, you're going to be choosing new poses potentially every frame. I apologize for bumping my microphone. And, well, you don't want to be orientation warping on the blend between those poses when you're pretty much always blending between poses. That can get messy. So the blend stack will separately apply everything you apply to the pose inside of it to the poses that are being blended. So if I'm blending between 3 poses at once in a motion matching node, because I've switched to 3 different poses, 3 different frames, and I have a blend time of 0.2, and maybe I'm capping my max active blends at 3, and there's 3 animations in the midst of being blended together. And the pose that gets blended is this output pose here. So we can apply orientation warping to the pose that gets blended with each other pose, which would result in a much cleaner blend. So this is very good to know. So it's applying orientation warping to the motion matching output, which causes the feet to move in different directions based on the locomotion direction. This can allow a forward walk to strafe at different angles, which reduces foot sliding. Currently, there's an issue with orientation warping when the animation is not moving in a straight line, which is why we use an Anim curve to only enable orientation warping during sections of the animations where the motion is straight. This should be fixed in a future release. So does that mean the whole pivot leg swing around is actually an issue that they're going to try and solve and not just, okay, that's interesting. And that explains why they disable the orientation warping during direction changes. How does the retargeting work? I haven't looked into the exact implementation, probably similar to what they've shown with runtime retargeting elsewhere, but they do cover it in the documentation page at that link. I haven't read through that yet, though. I'll probably get to that in a video relatively soon, though. So it's reading the curve. Interesting. So we can get a curve value from an animation that isn't currently playing. That's new, or something I wasn't aware of. So it looks like we can access a blend stack input. Is that in any blend stack? Because I don't know a lot about blend stacks. So let's get like a sequence player, something completely different. Double click into it to look at its blend stack, or I guess that only motion matching has that. That makes much more sense, I guess. Oh, I don't want to duplicate that node. Let's get a new motion matching node. Now that sucks, Maxim. You're welcome to always catch the recording of the stream. It'll be up on the channel. So if you'd rather just go and start exploring, I of course don't mind. You're welcome to do that. The recording of the stream will always be up on the channel, so you can always come back to it and watch it later. So what was that called in this? Loco blend stack input. Is that so like local blend stack input? Okay, so this is everything every blend stack seems to have then. And gets a reference to an anim graph node in this animation blueprint. So this is the reference to the node that the blend stack belongs to. That's my guess. That's something that every blend stack has. So this gets the current animation asset that is playing and the current animation at the time. You cast that to a sequence and then get the curve value from an animation. So this must be new, or can it only be called from inside a blend stack? Because I've never seen this get curve value from animation, only get curve value. Unless it's been around for a while and I just haven't been aware of it. That's really good to know. And I can input a time. This was not in Unreal Engine 4. Oh my gosh, trying to figure out distance matching manually before Unreal Engine 5 in all of the C++ and trying to figure out how to read curves like this. When did they sneak this into the engine? Gosh. Wow. Wow. I would have done so many things to get this node back in Unreal Engine 5.4 days. Gosh. That's a really useful node. That is a really useful node. Like, I'm just need to think about this for a moment, guys, because it could affect my strategy with stuff that I'm working on right now. In another project. For some animation selection and blend-in time logic. Okay, I'll have to think about that more in depth later. So back to our motion matching. So we get the curve at the current time and plug that into the orientation warping, pass in our last non-zero velocity, and the warp space. Is this new? Or am I just still, am I like unaware of something else? Component, root, or custom. Okay, I haven't paid attention to this setting before. But it's set to root bone. Okay, was it always set to root bone or did I break something? Don't know. Don't know. I just won't save when I close out of the project. So steering is new for 5.4 as far as I can tell, and I don't understand exactly what it's doing yet, or what this reset root transform does. This node applies additional rotation to the animation's root motion in order to steer it towards a target. The root motion is consumed by the offset root bone node, which handles the actual rotation of the root. This node is a heavy work in progress, and there are some unwanted behaviors that will be fixed in future releases. Why? I want to understand why use this and orientation warping. So is this meant for like forward facing? I don't know. I don't understand what the specific purpose of this is. So if it's going to rotate the root bone and the lower body by the specified angle while counter rotating the upper body. So isn't that just like orientation warping? So this is my biggest question, guys. Like, I've had this question for a while. I really don't understand what the point is of steering is. And it looks like they're using it for turn in place. And they just put in a really huge value for turn in place. So I'll have to check the documentation and see if they've added anything for steering, because I have no clue why this is used. Like, if it's used for when you're standing still, can be used when you're standing still. It doesn't get turned off during pivots. So why not replace orientation warping with it if it can be used at all times? Is it because you have to manually calculate a desired facing angle? We get our trajectory, get trajectory sample at time, and get the desired facing at 0.5 seconds in the future. Thanks, Highflex. Like, I understand that. What you're saying, it all makes logical sense to me, but I don't understand, like, why. I don't understand, like, what's a use case for steering. I don't understand how it, like, fits in, and I don't understand. I guess what I don't understand is the specific problem it solves that orientation warping doesn't. But I know there has to be a problem there. It seems like it would be useful. I just don't understand, like, what it's useful for. Not its function, but, like, what does it solve? What issue does it make? Does it get rid of? That's what I want to understand about this, and what I'm not understanding yet. I think I'll come to understand it eventually, regardless. So after that, we have an additive lean, which is just like a left and right lean. I like that it keeps one foot right underneath the root so that you're pivoting and rotating around that foot. That's the proper way you'd want to do leans, in my opinion. Simple aim offset. So this is all standard stuff. And there's dead blending for inertialized blending. And then here's our offset root bone. So like orientation warping doesn't offset the root bone. So like, oh, okay, I get it now. I think I'm starting to get it. Steering rotates the root bone. Orientation warping only rotates the legs and keeps the root bone. So steering could be like used with turn in place to steer it so that you're kind of could get a facing that actually aligns with what you're looking at. Or if I'm running and turning, the steering could be added onto that. Or if I'm pivoting, like that's going to actually pivot the facing of the root for when I'm doing forward facing stuff. I could kind of see that. And it's rotating the root towards where I want to be facing. Okay. I could see that. I would want to see like what the difference is when it's turned off versus turned on still, but I can understand a bit better where it could be used for, but still not fully. I don't fully comprehend its place in this system because it's such a new concept to me. offset root bone node dynamically applies an offset to the character's root bone in order to keep the mesh more planted when capsule movement and animation data do not match. For translation, the root is allowed to deviate from the capsule within a fixed radius during locomotion, which is most noticeable during starts, pivots. When stopping, the offset will release or blend out, so that the character stays at the capsule center when idle. See get offset root translation mode function for more information. For rotation, the root bone is allowed to rotate independently from the capsule, so that rotation is entirely controlled with root motion, which gets steered within the motion matching node to always align towards the target. So this is where steering, I guess, is applied and separates the rotation from the capsule. This makes it easier to perform more complex rotational animations like turn in places, turn starts, and turn pivots. See the get offset root rotation mode function for more information. Known issues that will be fixed. Translation offset has no collision check, so it can clip into geometry. When a montage plays, we release the offset. However, the release in conjunction with motion warping in the montage might cause undesired movements. How the offset is interpolated out is hard-coded at the moment. So I get, like, it makes sense that this could make rotation easier. I still don't understand how it makes the rotation easier. Like, I get there are so many issues with rotation and stuff. Like, it's difficult. Turn in place is just hard. Like, what I don't see is a rotate root bone node. So this is replacing the rotate root bone. And maybe instead of, like, tracking a root yaw offset, it's just doing that implicitly. It's automatically offsetting it based on, like, a desired facing with the steering node. Maybe that's it. So somehow steering and the offset root bone have replaced, like, a root yaw offset? Huh, that seems to be the case. That is interesting. That I'm really, really, really curious to understand, because I get the root yaw offset turn in place approach. This is, like, fundamentally different. So I really need to understand this now, because that could be like a dedicated video, definitely. Leg IK and pose history. So that's the Anim graph. Not super duper complex, a lot simpler compared to, like, a complex state machine system, but a lot of new concepts I'll have to take some time to get familiar with. And then we have our event graph. They're saying there are, like, some thread safe issues with getting tags, so maybe that's why they're not doing this in thread safe. So setting references on initialize the animation. If the character is valid, update essential values, generate trajectory, and update states. So update essential values. A lot simpler than the Lyra. Get a transform. Okay, that makes sense. Why store location rotation separately? Just combine it in a transform, make it simpler to access. Coaches or caches the root bone transform from the offset root bone node if possible. Storing the offset this way instead of using the get socket transform function ensures a more accurate value, since skeletal meshes are rotated negative 90 degrees by default in editor. An offset is added to make angle comparisons against other transforms easier. Okay. So if that's false, set root transform with the character transform. If it's true, it gets a reference to an anograph node in this animation blueprint. What? You can get references and event graphs? What the heck? Node reference. Is this new in 5.4? Okay. So that blend stack input. So how do you make node references? Are these variables? Doesn't look like it. So if you put a node in an animation graph, do you get a reference? I need to start taking notes, guys, because there's going to be a lot of new concepts here that I really need to understand. So I need to make sure I remember to come back and look at this. Okay. So we can reference the offset root, get the offset root transform, break it. add the 90-degree offset because the skeletal mesh is rotated 90 degrees. Okay. Oh, hey, Caleb. Great to see you. Wow, you're on my stream. That's kind of crazy. Huh. Thanks for releasing the Advanced Locomotion System version 4. It's where I learned a lot of what I know. So, cool to see you here. Welcome to the stream. I am doing my best to pick this apart and try to understand it. I'm looking forward to getting more information from you guys at Epic, because I would really appreciate a lot of it. So I don't know a lot of what I'm talking about with this project here, but I'm doing my best to understand it and thought it could be fun to try and stream the process to my community here. Yeah, maybe I'll have to make this. So yeah, so lost my train of thought a bit there. So we're saving important information about the character's acceleration. That makes sense. That's standard stuff. Saving important information about the character's velocity. Standard stuff again. Awesome. That's great to hear. I'm really excited for that live stream tomorrow. I'll definitely be watching. Okay. So that all makes sense. We're getting values and from relating to the character movement. And now here's the trajectory stuff. So this function updates the trajectory history and generates a future prediction using the motion model from the default character movement component. Custom character movement components may need a custom generate trajectory function. Montage root motion and warping will not affect trajectory generation. Okay, that makes sense. Okay, thanks. That's good to know. I guess I was completely unaware of the Anim node reference stuff. That I could see being quite useful. So I'm happy I know about that now. So we take in the animation instance, take in trajectory generation data. So does this mean we don't have like a trajectory component on our character anymore? And we generate this in the animation instance? That's interesting. No, we take in our trajectory, I guess. Okay, so let's find the references to this. I've just been plugging the trajectory from the trajectory component directly into my motion matching stuff. Oh, hey, what's Orica? Wow, definitely the most popular stream I've done so far on the channel. By far. Okay, so we're keeping like oh, I see. We're taking in a reference to the trajectory so that we can track the actual trajectory over time inside the function. Kind of curious to see what the code in this looks like. Okay, that's a lot of code. Maybe I'm not as curious as there was a moment ago. I need to figure out how to make Rider the default way this opens. So it's calling some functions down here. This needs to be color-coded better in Visual Studio. Maybe, probably just because it's still loading stuff up. But I don't want to go down a C++ rabbit hole with all of you guys here, unless you guys are interested in that. So this function takes the generated trajectory and applies gravity over time, and also uses traces to predict collision. So this, I guess, is where like this stuff can be different than the trajectory component, because it didn't seem like it was taking into account a lot of that stuff. I want to understand content, blueprints. Okay, so yeah, there's no trajectory component on the character. So this seems to be the way to do it now. That's interesting. Each trajectory sample at time node grabs a different trajectory position in the future based on the time input pin. That's useful. Interesting. So we're using this to determine whether the character is stopping, pivoting, etc. That makes sense. Super useful to have like a future velocity, because that could really simplify a lot of just the logic for detecting these different states. So in trajectory, time 0.5, time 0.4, and we're subtracting that. So this is the difference between 0.5 and 0.4 seconds in the future multiplied by 10. Okay, so we're getting the velocity. It's because we're getting the by the times 10. It's still okay. Thanks, Caleb. YouTube is blocking the work in progress. The little emoji thing was covering up one of those words in your message. But that's great to hear. So yeah, this is very interesting stuff. A lot of new information for me to go through. Very excited for the stream tomorrow. I'm definitely going to catch that. So why are we multiplying this by 10? It's probably, wouldn't this be delta time? We're getting the velocity, the difference in velocity. I mean, the difference in position, which gets us velocity. And then we multiply at a, because it's at a 0.1 second interval. So we're converting that to velocity in terms of seconds. Got it. That took me longer than it should have. Gosh. Okay. So this is just getting us from the position we're calculating the velocity in terms of speed per second. So in units per second. And so finally, in our event graph, what else do we have? Our update states. So this is what I'm really interested in, because this is where we're updating the states. So yeah, that was totally redundant right there, what I just said. But this is replacing the state machine logic, the state machine transition logic, and setting the enumerators that are being used in the choosers for the system. So takes all the important gameplay relevant states that the character is in, as well as saves the last frame's value so that we can determine when the value has changed. It saves them into easy to read enumerators for convenience. Okay. But that's what it seems like. Yeah, that does runtime retargeting, and it looks like there's some stuff in the documentation that shows adding new characters in. And I'll try and, once I figure that process out and how it's supposed to be done with this project, I'll definitely make a video on that to relay that to you all as best I can. So we're saving the mode from the last frame. That makes sense. So we're just getting the movement mode from the CMC. Okay, that's sensible. Rotation mode. That's checking whether or not we're orienting our rotation to movement or strafing. So I do want to see where the rotation mode is being used. I guess that's probably in the choosers, but if is it being used anywhere in the animation graph? Oh yeah, it is. It is. I just had to scroll up. So, okay, here. Enable aim offset. Okay. And it's changing the detection threshold on the pivot for the actual angle. The angular threshold in degrees based on the rotation mode is what that looks like to me. Got it. Okay, that's cool. It's a nice way of sending the data around and using it. So movement state is moving or idle. Gate, that all makes sense. So I'm curious to see how they are actually handling gate in this. So we're saving the character stance and saves the last frame's value. The stance enum describes whether the character movement component is in the crouching mode or not. Okay. So then this is all the stuff that gets passed into the chooser and used to an extent elsewhere. So relatively simple event graph, really quick and easy to move through. So great job on the system, guys. Really. This seems very efficient when it comes to the amount of logic compared to the fidelity of the result. The whole chooser system is fantastic. We're really excited to get to using that more in my own systems. I believe that the live stream from Epic will be sometime tomorrow afternoon, probably the same time as their usual. Insight on real streams, but someone in chat can probably answer that with more accuracy than I can. Okay. So when it comes to adding like punching and sword swinging, like so this is handling locomotion. In a lot of cases, those sorts of things will like blend over and just let an animation montage, potentially with motion warping, take control. But they are using motion matching to select montages to play for the parkour and everything in this. So they're using aspects of motion matching to select animations based on the environment, and that certainly could be done for like swinging a weapon at an enemy or punching. Definitely, you just have to look for the right features to match against. I haven't gotten to that part of this yet. We're an hour and 48 minutes into the stream. I'm not sure how much longer I'm going to stream for today, but we can definitely switch over to the character because I would like to understand a few things here. I won't be able to make an example of that in the stream. I can try and find where they're doing some of this stuff with the vaulting, mantling, the climbing, and jumping stuff that they have in this project. But that would be something for a video down the line to explore more and how we can apply motion matching to montages. But yeah, in the future, I'll definitely look into that. Okay, that's interesting to hear about the state machine stuff. So here's our perform traversal action event. So we're updating motion warping warp targets here. So there's separate targets for like the front ledge, it looks like. Logic to remove targets. I'm not going to go into this as in-depth during this stream right now as I did the actual animation system, just because I want to get through it relatively quickly and get an overall understanding of how the animations are being selected, more so than how the motion warping is applied right now. So, okay, this traversal result, where is this event getting called? So that's what I'm want to find. Perform traversal action. I could probably find it in the input. Yep. Okay, so this is our try traversal action. So this is probably being called off of an input action. Don't know why I typed offset. I guess I really cannot type today. There we go. Yep, okay. So input action jump. If we're not currently doing a traversal action, and if we're moving on the ground, we're trying a traversal action. If that failed, we jump. Okay, that makes sense. And I'm going to catch up on chat too for a moment. Okay. So we're getting the actor location, forward vector, capsule radius, and capsule half height. Doing a capsule trace with that information against visibility channel. Out hit actor, so there's a traversable actor type. Okay. And component. So, okay. So this traversal check. So each so okay, so let's look at the level here. I think I'm seeing how this is put together. Oh yeah, I'm way in the sky here. Let's focus this in. Oh, I sped up the camera too. Okay, I won't. I'm actually a bit interested in this for my own project. I'm curious to see how you guys are defining the ledges and such. So it looks like, yeah, the actor holds the information that's traced and pulled from that. So, okay, I can look into that more later. Okay. So that's making the traversal check result. Got myself a bit lost. Oh, I ended up in the level block traversable because the function's implemented there. Okay, that makes sense. So at this point, lots of information is being gathered. So defined by spline components. Okay. Okay, yeah, fully dynamic system would be awesome to see an example of. I'm probably not going to be working on a lot of traversal stuff, but a friend of mine who's on a team with me has been looking into that recently. So we'll probably both take a look at this project together at some point to try and pick it apart and compare it to his approach, which I believe is fully dynamic so far. So there's a blueprint interface for interaction transforms. Okay, so this is the part I'm very, very interested in. So with choosers, you can pass in context through structs, and that's what's going on here. In this case, this chooser takes in an action type, gate, speed, obstacle height, and obstacle depth. Okay. So we evaluate the chooser, return the results, and motion match within these results from the chooser. We take the selected animation, cast it to a montage, set the data, and then perform the traversal action. So we're setting this through a reference. So this is setting this struct right here, everyone. So now we have all the data we need. We've done our lookup in our chooser. And so I do want to actually take a quick glance at the actual chooser there. So hurdles, vaults, mantles based on an enumerator for an action type, and these are nested choosers. And they're being switched between based on obstacle depth and speed. That makes sense. Okay, cool. I'll look into these a bit later. So from that result, we can get the montage and play it with a play montage node. So this, I think, is really, really cool, being able to match against custom features. So that's what I need to go back and look at too. And to do motion matching to find the start time and play rate and animation for a montage. Like, that's just really interesting and definitely something I'm going to be looking at for my own systems, specifically with combat. Not anything I've really shown on the channel yet, though, as far as that project goes. So my biggest question I have here is, okay, so it's going to be the database. We're providing databases here. And so if I go to one of these databases, I guess I just answered my own question. Oops. Went a bit too far. Okay, so we have a chooser table full of animations. So are they not in a database then? Okay, so we're motion matching without a database using a pose history node. So, okay, so how do we choose the channels that we're motion matching? Where would I find what's the name of the asset type? The pose search schema, or whatever equivalent is providing the features to match against. It's probably right under my nose here, and I'm just missing it though. Okay, thanks, Caleb. I really appreciate it. A ton. Okay. Ah, I see. So if we provide the array of montages into the motion match node. And the montages have notify states with pose search. So then this is telling this motion match node here where to pose search these animations, it seems. Okay. So that's... Oh, so is that why these are blue? Or not blue, but like a turquoise color? And not the normal white? Okay, that's my guess. And then, so that's how we get to the traversal schema. Okay. That's really interesting and really good to know. So thanks for the help there. So there's a trajectory channel. And here's that what they showed in that brief feature highlight, I think. Yep. Mannequin animations. Can I just go to the file there? No. Okay. Animations, motion matching data, channels. So UEF and mannequin animations, motion matching data. Okay, got it. Get interaction transform, rotation. Okay. Get world position. Parent class position channel. Okay. And so it's... I think I see... Oops. Okay, yep, so these are override functions. Got it. So the database needs to be built before you perform a motion match, so the frames are added to a database with a schema beforehand. Okay. This is something we're improving for 5.5. There's already a ton of code fixes on main for things. This should be a non-issue in a future release. Okay, that's good to know. Thanks, guys. So I'll definitely take some time and reverse engineer this montage motion matching stuff to get a better understanding. Looking forward to that, and might do that this evening, actually. Okay. I see. So if I'm passing in a montage, the montage would need a pose search notify, and that's telling it which database to reference for the montage, and it needs to be in that database, and the database needs to exist. Awesome. Okay. Cool, cool. Well, all right, everyone. We've been going for about 2 hours now. I'm not sure if there's really much more I can cover, because at this point now, it's probably just going to be a case of me needing to take some time to go in depth and start picking some of the specific things apart, and also just watching the live stream tomorrow. I'll definitely be around for that. But a really awesome project. I'm really excited that it is now out. And well, thank you guys for watching the stream. I appreciate it. definitely the best a stream has performed on the channel so far. It makes sense. The credit for that goes to Epic for this awesome demo here. So I'll be definitely working on understanding this, and once I am confident enough, I'll try and make some videos to go over the individual concepts in a bit more detail. But yeah, I'm looking forward to that demo, Caleb. And yeah, I'm not sure if I have much else to say. I'm never too great at actually ending off these streams. Tend to meander on a bit. But before I go, does anyone have anything else they'd like me to try to pull up and look at? I probably won't explain things too well, but I can do my best. But again, the disclaimer here is that this project is just as new to me as it is to all of you guys, so take anything I assume while looking at this with a sufficient amount of salt grains, or grains of salt, or however you want to say that. The runtime retargeting is one more thing I could look at. Okay, which widget would you like me to open? I'm assuming the game animation widget. I think the controller representation here is really nice. Okay, timescale controls. Oh, cool. I did not see this menu to expand before. These are some really useful controls here. That's cool. I'm definitely going to have to pull this widget out into my own project. This is so much better than just typing in all these console commands. My goodness. Wow. Yeah, the fidelity on this is really nice. There's a really good amount of coverage. You can really see the smoothness with the transitions between all of these different animations when I just go crazy at the keyboard here. I'll have to plug a gamepad in. I don't have enough USB ports on my computer, so I don't want to have to unplug anything that I'm using right now for that. So I won't be doing that on this stream, or I'll have to lose a microphone probably. Oh, cool. Yeah, I'm not too sure about like implementing this into a Lyra-based locomotion system. There are so many different new ways to do things, especially with the chooser system compared to like the linked anim layers approach. So it probably is like really situational. Like, yeah, I don't know. It's like another tool in the toolbox, but it does really facilitate an entirely new way of approaching constructing these systems too. And yes, Bad Radish, it is out. You can download it from the launcher now. What's the motion matching query? Did not mean to keep automatically hitting my keybind for stopping the play in editor instead of freeing up the mouse again. Yeah, the still cam is more useful than I would like. I wouldn't have thought to use a still cam to debug this stuff before, but I definitely will be now. It just gives you a totally different view and perspective on this. Easier than trying to, rotate the follow cam around. Okay, I see. So there's the hip facing and the feet queries for the motion matching. And then I can disable the root offset. So yeah, I'd want to see, okay, yeah, there's definitely, okay. So I can really see how that's helping. The animation doesn't have to match the rotation nearly as well. Okay. And how does that compare to like forward faced? Oh, wow. That is really interesting. I want to see what the capsule rotation looks like. So for those of you who were just hopping in, because it looks like, gosh, I get towards the end of the stream and more people jump in. I should have started this a bit later, maybe. Let's see. So I have root offset turned off, everyone, and that's why this is jumping around so much. I'm just trying to get a better feel for the effect it has. So don't worry, those of you who are hopping in, it's not bugged. Okay. Let's look at that more and try to understand that, because I haven't used the offset root bone node before. So understanding how that's applied and how it helps and why the locomotion looks like the way it did beforehand would definitely be helpful, because there's probably saves a lot of steps. Okay, gotcha. Oh yeah, because the orientation, I was doing a lot of pivoting and it's turned off for that, so that makes sense too. Okay. The positional offset is really interesting too. Oh. And the root offset, I definitely want to look at that more, because I've thought about offsetting the root from the capsule and how useful that could be a lot of times, especially on like pivoting motions and rotating relative to the foot that's planted. I don't know if this is doing anything like that. It seems like a lot of positional offset is happening that helps, especially when it's almost like feels kind of like a spring interpolation going on that matches the animation more closely. So yeah, I'm excited to crack that open and really understand how that node works. Oh, hey, Ryan. Yeah, you are late to the party. I'm not sure how much longer this party is going to last. Okay, cool. I'm curious to see where the root offset goes, because I still don't fully understand. Like, I see what it does. I'm just still trying to work it into my like mental model of how do you build a good locomotion system. That's lagging behind a bit, and I'm getting overloaded with all the new concepts here, which is super awesome and super exciting. Yeah, I'm still really happy with the fidelity of the movement here. Like, there's so many great animations. That's going to be really fun and really useful. So I'm curious to compare the sparse level of detail now. Yep, so do I, Ryan. I mentioned that earlier of how we could probably look at that together sometime. They're using splines to define the shapes. Right now, Caleb did mention he'd like to maybe do something fully dynamic in the future. But they have a pretty robust system for handling what they are handling right now. And if we wanted to, for our game, we could probably stick to a defined set of shapes if we really wanted to and not worry about the dynamic stuff. But I'm still down for us to try and figure that out too. Definitely something we could discuss together later today sometime. But yeah, super duper smooth vaulting. Like, feels just really, really nice. Ah. Okay, so the last thing I want to look at during this stream is the retargeting stuff, the runtime retargeting. Also curious to compare this UE-FN mannequin to the UE5 mannequin with the actual skeleton itself to understand what the differences are since this is being used as the base. Are there any insights I can pull from that? So if I look at the actual character and the mesh, that's set to this, and then is there, I wonder where that's getting reset at, or changed at. So it's using the sandbox character Locomotion. I'm just going to filter this for animation blueprints. That would make the most sense. There we go. Oh, that's post-process. Post-process. So I'm familiar with the approach. Interesting. I'm pretty deep into the content. Okay, there we go. There we go. So post-process animation blueprints. So I'm familiar with the approach where runtime retargeting is done from a second animation blueprint on the mesh. Like, it always seemed like a weird approach to me to have two meshes inside the character class I never really liked. So I bet that's mentioned in the documentation, though. I feel like it is. So I'll probably just look into that myself another time, or I could just glance at it here on stream before I end things out. So importing your own character. So iCarry targeter, that makes sense. Set up an iCarry targeter. So there's blueprints, retargeted characters, and open the generic retarget animation blueprint. Okay. Select the iCarry targeter map variable into my blueprint panel and expand to add something to the map. Okay. A child blueprint of the sandbox character. So, okay, so we are adding a second mesh. And using the blueprint. So it is still that approach. Okay. Okay. That's cool. All right, everyone. Well, I do think I am going to leave the stream off here now. I really don't think there's much else useful that stumbled over my tongue there. I apologize. I don't think there's much more benefit I can add just by streaming myself fumbling around through here. I'll be working on videos and picking this apart. You guys have any insights, you're welcome to join the Discord for the YouTube channel and share them here. Let's see. I need to grab the invite link. So that's in chat right now, everyone. So you are all, of course, welcome to join the Discord. Trying to build a community there, and I'll try to be more active. I know I don't respond as often as I should. I apologize, everyone. I'll try and spend more time in my own Discord. I know I really should be better at that. So runtime retargeting is also a very hot topic. This is the first time I'm really putting the tools through its paces in a gameplay context. Okay, cool. That's good to hear. I just think it's pretty awesome that we have runtime retargeting in the first place. So you guys are doing great. Thank you all for watching the stream, and I'll see you all around. Definitely everyone check out the streams that'll be going on tomorrow from Epic and others who have actually worked on the system. They'll be able to answer questions much better than I will, and I'll see you guys there too. I'll probably be hanging around in chat. So, all right.